Do you have any women in CS that you look up to?
I honestly don't have any female role models in CS. I never learned much about women in computing, and the times that I did, it was because they were breaking stereotypes and gender roles by simply being women in computing. I never actually learned about what they did.
Have you ever heard of Grace Hopper and her work before?
Heard of her anecdotally, and I know she contributed a lot to the field of computing. However, I don't know much about what she actually did.
So who was Grace Hopper? Was she simply an early female computer scientist? No. In fact, she was instrumental to the progress of the world of computer science by arguably being the mother of modern programming languages by inventing the compiler, and thus should be an influential role model for women in computer science. Before her work on the compiler, Grace Hopper began her career in programming in the Navy. Although she was initially turned away because of her size and age, she was placed into the reserves and was commissioned to work at the Bureau of Ships Computation Project at Harvard University, where she worked on the first automatic electronic computers called the Harvard Mark I and Mark II. Funny enough, one day in 1946, Grace Hopper would discover a moth in one of the relays of the Mark II, which ruined her code. She would tape this moth to her daily logs and write, "First actual case of a bug being found." Many historians would argue that this was the start of the term debugging, to signify fixing code. After her military service in 1949, Grace Hopper began working for Remington Rand. There, she worked extensively on the development of UNIVAC, one of the first large-scale commercial computers used by private businesses. Although UNIVAC was designed for private businesses, it took a trained programmer to code on the UNIVAC since it used a computer language entirely made of non-English phrases and extensive use of symbols. Thus, while working on the UNIVAC system, Grace Hopper began theorizing with co-workers about creating a computer language that was made entirely out of English phrases. But because this code could not be understood by a computer, it would have to be synthesized by a machine, called a compiler, which would turn it into machine code, which a computer could read and execute. But in a similar fashion to her experience in the United States Navy, she faced rejection as her contemporaries rejected her ideas to make computing accessible to everyone through a user-friendly language and machine which could turn that language into computer-friendly code. Despite backlash, she would write papers on her idea of a compiler and would eventually give a speech on compilers at the Association for Computing Machinery, where she famously stated, "It is the current aim to replace, as far as possible, the human brain with an electronic digital computer." Soon after her speech, her company released one of the first compiler-based languages, named A0, which would spark a variety of other companies, such as IBM, to produce their own compiler languages for academic applications. However, Grace Hopper wanted her company to create a new language for private businesses because she knew businessmen would not want to learn difficult computer languages. As she put it, "I was charged with the job of making it easy for businessmen to use our computers. I found it was not a question of whether they could learn mathematics or not, but whether they would. They said, 'Throw those symbols out. I don't know what they mean. I have not time to learn symbols.'" Thus, in the late 1950s, under her lead, Remington Rand released Flowmatic, a computing language designed for businesses to manage their data. After the release of Flowmatic, Grace Hopper went on to become a technical consultant in the formation of the first nationally recognized and standardized compiler language named COBOL, which would go on to become the most widely used computing language to date, with over 70 billion lines of COBOL still actively being used within organizations. Without COBOL, without the Flowmatic, without A0, and certainly without Grace Hopper, the world of computer science would not have been able to develop into one of the most influential fields in society. But sadly, most people outside of computer science world know little about Grace Hopper, the hidden figure who changed our history significantly. And even fewer likely know about our own hidden figure right here at Georgia Tech, Bonnie Ferry. Bonnie Ferry is Georgia Tech's first female PhD graduate in electrical engineering and the Electrical and Computer Engineering Department's first female faculty member. She was hired in 1988, and currently she is the Vice Provost for Graduate Education and Faculty Development at Georgia Tech, and a professor in the School of Electrical and Computer Engineering, which now has 13 women faculty members. Prior to working at Georgia Tech, Bonnie received a bachelor's degree in electrical engineering from the University of Notre Dame and a master's degree in mechanical engineering and aerospace engineering from Princeton University. She then worked for the private sector for 2 years prior to returning to school to earn her PhD in electrical engineering from Tech. She now has more than 59 publications, not only on topics related to electrical engineering, such as embedded control systems, but also on advancing engineering education. Testimonies from her students prove Bonnie's hard work and dedication in pushing forward Georgia Tech's education style. One of her students said, "Amazing teacher. Her teaching style is not the norm, and that's what's so wonderful about her." Another student said, "It is a privilege to be one of her students. She's one of the most compassionate professors I've ever had. I have a deep understanding of linear circuits and even enthusiasm towards them because of Dr. Ferry and this class." After 33 years on the faculty of Georgia Tech, Bonnie Ferry has become an accomplished engineer and a celebrated educational innovator. She has received many awards because of her mobile hands-on learning and her development of inexpensive portable experiments in ECE courses. Her academic and professional career within the male-dominated mechanical and electrical engineering fields and what she is able to accomplish with it are a source of inspiration for aspiring female engineers. Her advice to young women is to be confident in their skills and abilities and to project that confidence to others. They should be willing to be bold in making suggestions and voicing opinions. Both Grace Hopper and Bonnie Ferry are pioneers in their education and in their work. While we recognize their impact, the rest of the world doesn't. We want you, as students, as women, as engineers, to remember their stories and to be as fearless as they were by continuing to pursue an education and eventual career in STEM. They have paved the way for women in electrical engineering, aerospace engineering, and computer science, which we need you to continue. When we asked a female first year majoring in computer science about being informed about women like Grace Hopper's impacts in the CS industry, she answered us with this quote.
"I do wish I knew more about what women in CS have actually done. Whenever women in STEM fields are discussed, they are usually praised for the confidence and perseverance it takes to stand up to authority figures in a male-dominated field and be a woman in STEM, but their actual work is rarely mentioned. If I had grown up hearing about the positive impacts people of all genders made on my field of interest, I would understand that it is my work that matters equally as much as anyone else, and that my gender identity should not be important to my profession."
We want every young woman entering a male-dominated field to feel this way. So if we can express one final message for women to take away from their stories, it is to stay bold, stay confident, stay passionate, and stay in STEM.